Let's start the question, which is question 31. Water samples X and Y from two different sources were brought to the laboratory for the measurement of dissolved oxygen. Okay, so there are two samples X and Y, and they were brought to library to measuring the DO value, and they are using modified Winkler method. Samples were transferred to 300 ml BOD bottles. 2 ml of MnSO4 solution and 2 ml of alkali azide reagent were added to the bottles and mixed. So 2 ml of MnSO4 and this reagent were added to the bottles and mixed. The sample X developed a brown precipitate, whereas sample Y developed a white precipitate. In reference to these observations, the correct statement is, we have to tell that whether the both these samples were having devoid of DO, that means there was no dissolved oxygen, or in any one of them was the dissolved oxygen, or both had this dissolved oxygen. So for this we should know one thing, that in absence of oxygen, we get a reaction of MnSO4. This Mn plus ion will react with 2 hydroxyl ion and will gives MnOH whole twice. It is a precipitate and it is of white color. Now, in presence of oxygen, oxygen, your MnSO4, that means Mn2 plus ion, reacts with OH minus ion, and presence of oxygen, then oxygen is there. It gives MnO2 precipitate, that is of brown color. Okay, so in absence of oxygen, Mn will react and give white precipitate, and in presence of oxygen, this MnO2, that means it becomes a brown precipitate. They are saying that sample X developed a brown precipitate. That means brown precipitate means you have a presence of oxygen, that means sample X is having oxygen, whereas sample Y developed white precipitate. White precipitate means you have MnOH, that is white, and that is absence of oxygen, right? So Y is having absence of oxygen. So the right option will be option C, sample X contain DO while sample Y has devoid of DO. This is the way we should test the questions. Now let us do next question, which is question number 32. A portion of wastewater sample was subjected to standard BOD 5 days test, yielding a value of 180 mg per liter. The reaction rate constant to base E at 10 degrees Celsius was taken as 0.18 per day. The reaction rate constant at other temperature was estimated by this one. Now we have to calculate the BOD in 2.5 days. See, the thing that is given, first of all, BOD 5 days 20 degrees Celsius, the value was 180 milligram per liter, and they have given that reaction rate at 10 degrees Celsius is 0.18 per day. Okay, the reaction rate constant equation is also given, that KT will be calculated by K, this equation 1.047 to the power T minus 2. The temperature at which the other portion of the sample should be tested to exert the same BOD. Same BOD means same amount of BOD that came to 5 days 20 degrees Celsius within BOD within 2.5 days, at what temperature we will get the same BOD? Alright, so see, we have given K10, the value of BOD at 10 degrees Celsius. BOD 5 at 20 degrees Celsius, it's going on. It will be, equation will be L0 1 minus e to the power minus KT. This is at 20 degrees Celsius, K we will put at 20, but we don't know that, right? So from the equation we can calculate what is the value of K at 20. So how will we calculate? K at 10 is given, that is 0.18. Let's calculate K at 20, that will be 1.047 to the power T minus 20. So from here we get the value of K20 as, so we get the value of K20 as 0.28. 0.28 per day, I can say that. Now see, so I have K value. Can I calculate the ultimate BOD that was here? Yep, we can calculate. That was, so ultimate BOD value will be BOD 5 at 20 degrees Celsius, L0 1 minus e to the power minus K at 20 into time. BOD 5 was 180 at 20, L0 1 minus e to the power, I got K20 as 0.28 into 5 days. So by calculating this, I get L0 as 238.91 milligram per liter. Alright, we got the ultimate BOD now. So now can we calculate, see what do we want? We want BOD 2.5 days at what temperature, right? So see, and but the value is equal to 180 degrees Celsius. Okay, so this is given, the value is given, but temperature we don't know. So can I say that this 2.5 days BOD is nothing but L0, that is always be same, right? 238.91, 1 minus e to the power, K I don't know, right? K I don't know, but time I know, time is 2.5, so K into 2.5. So from here there is only K that is unknown. I have calculated, the value of K comes out to be 0.566 per day. Okay, and see now what is the this value? This is K value of the temperature that we wanted, right? So I got the K value, but I don't know what is the temperature. I know KT, I know K20. KT is equal to K20 1.047 to the power T minus 20. KT will be 0.56. K not K20, I can say K20 I got 0.28 into 1.047 T minus 20. So from here, after calculating, I get T as 35.09 degrees Celsius. So is that in the option? Yes, option D. So the answer is T 35.09, option D. So this is how we calculate. If the concept is in our mind, we can just approach towards the what do we want. See, first thing is concept you should know, another thing is question you should know properly. I have seen the solutions in the books of this question, but that is not correct. I have seen they have taken it as K20 only. That's not good. Like at 20 degrees Celsius K value is different. They have given it as 10 degrees Celsius. They calculated and they get an answer as 35.0 degree. But how? The method was incorrect. So this is the correct method to approach towards this type of question. Now let's see the next question, which is question number 33. For that I need some clear space. All right, let's move on. Question 33. An analysis for determination of solids in return sludge of activated sludge process was done as follows. See, the thing is that they have given these four things or the methods how they were proceeding in this activated sludge process. So they have taken a crucible. First is a crucible is taken and it is dried, and it has the mass of, after drying, 62.485 grams. So I can say the weight of crucible is equal to 62.485 grams. 75 ml of well mixed sample was taken in the crucible. They have taken the volume of sample is 75 ml. Okay. Now next, in third step, they have done that crucible with the sample was dried to constant mass of 65.02 gram on a drying oven at 104 degrees Celsius. So at 104 degrees Celsius they have dried the sample, and the sample plus crucible weight plus, I can say, weight of crucible plus sample, that comes out to be 65.02 gram. From here I can say that the weight of sample is 65.02 minus 62.485. That comes out to be the weight of sample 2.535 grams at temperature 104 degrees Celsius. Right? Okay. Next, what they did that the crucible with the dried sample was placed in a muffled furnace. Then after that they placed the crucible in muffled furnace at 600 degrees Celsius temperature for an hour. After cooling, the mass of the crucible with residues was 63.154 gram. So at 600 degrees Celsius, what is removed from the sample? The organic matter was removed. Okay, so the organic matter was removed, and after the full removal, the weight of sample plus crucible was 63.145. So at 600 degrees Celsius, the weight of sample, I can say, that is 63.145 minus 62.485, and that comes out to be 1.875 grams at 600 degrees Celsius. Now what do they want? They want that the concentration of organic fraction of solids present in the sludge sample is, see, they want the concentration of organic sample. Concentration with, see, the weight of sample is this, right? Okay, now this is organic sample that was removed, right? So this is the weight. Now what they want the concentration. Concentration is always weight upon volume. So see, 1.875 gram out of how much was the volume? 75 ml, right? 75 milliliter. The value we have got. Just now what we have to do, we have to change this gram per milliliter to milligram per liter. Okay, so 1 gram, so this is equal to 1.875. in gram there is 10 to the power 3 grams, and in milliliter there is 10 to the power minus 3 liters. So it is 1.875 into 10 to the power 6 divided by 75 comes out to be 25,000. So weight of solids in liter was 25,000. So this is the question. This is how we attempt the questions of wastewater treatment.